All right, this is the new unit in geometry. It is called circles. And this is lesson 1. This is called circles and circumference. Okay. So as far as what circles are, that's the first definition. A circle is the set of all points equidistant, meaning the same distance, from a given point called the center. Okay. Okay. A circle is the set of all points equidistant from a given point called the center. So in this circle below, this is the center. Okay. And every point on the circle is the same distance from the center. Okay. So the distance from A to the center C is the same as the distance from B to C, which is the same as the distance from D to C, and E to C, and F to C, and any other point on the circle. You name a circle by its center. So for example, the circle below is called, and this is how you write it, okay, circle C, okay. You could write out the word circle, but this is the symbol, okay. Circle looks like that, has a little dot in the middle, okay, circle C. Okay. Now a few terms that you need to know. There's 3 of them. You probably know 2 of them. Maybe you know all 3. Okay. Any point with endpoints that are the center and a point on the circle is called a radius. Okay. So for example, CD, that's a radius. It goes from the center to a point on the circle. Another example would be CB. CB is another radius. Another example would be CE. CE is another radius. Okay. So that's what a radius is. The other one, well, let's start with the chord. You might not know what a chord is, okay? Any segment with endpoints that are on the circle is called a chord, okay? So for example, AF is a chord, okay? It's a segment, and both endpoints, A and F, are on the circle, so that's called a chord. BE is also a chord, okay? It's a segment, and both endpoints, B and E, are on the circle, so that's called a chord. A chord that passes through the center is a diameter, okay? So a diameter is a special kind of chord, okay? For example, BE is a diameter because it goes through the center, and both endpoints are on the circle. Okay, so BE is an example of a diameter. Okay, so example 1, identify the key parts of the circle. Okay, so example 1A, name the circle. You name a circle by its center. So I'm going to say circle K. Or you can actually write out the word circle. You can write out circle K if you want. I'm going to use the symbol, okay, circle K. Part B, name all the radii. That's the plural form of radius, okay? Name all the radii of the circle. Okay, so I'll start with the center and I'll work my way to the circle. So I'll start with a KN is a radius. Also KO. Also KP. Notice how I'm writing it. It's a segment, so I put the bar above it. Also KQ. And then KR. Those are all the radii. There's 5 of them in this diagram. Don't forget the segment bar above it. Name all the chords of the circle. Okay, so a chord, remember, is a segment that has both endpoints on the circle. So for example, NO is a chord. And again, don't forget the bar above it. And the only other one is PR. And then name a diameter of the circle. So a diameter is a special kind of chord that goes through the center. So the diameter would be PR. Okay. By the definition of a circle, the distance from the center to any point on the circle is always the same. Okay? So therefore, all the radii are congruent. Okay? That's by the definition of a circle. So if we just look at this diagram right here, okay, AP, I think we talked about this in the first page, AP equals AD, which equals AL, which equals AG, which equals AF. All the radii are congruent, and they equal. A diameter is composed of two radii. So all diameters are also congruent. The letters D and R are used to represent the diameter and radius in formulas. Okay, so this means that diameter D equals 2 times the radius. Okay, diameter is 2 times the radius. And if you think about it the other way, the radius is half the diameter, or the radius is the diameter divided by 2. So example 2. All of these examples are independent, so we're going to do each one separately. So I'm going to use a pencil for each one. If DF equals 10, that's the entire radius. I won't label that. It'll be messy. Okay. If the entire radius, the diameter, the entire diameter is 10, find DA. Well, DA is the radius, so it equals 1/2 the diameter. So DA equals 5. Remember, when you say a segment has a certain length, you do not put the bar above the segment. You've done that a lot this year. Okay, so part B, which is completely independent from A, so B has nothing to do with A. Let's restart. Now let's say PA equals 7. Find PG, so PG is the diameter. So the diameter PG equals 2 times the radius of 7. So PG equals 14. Let me erase that 7 because that has nothing to do with the next problem. Part C, if AG equals 12, find LA. Well, again, we've talked about this before. All the radii are congruent. That's written above, okay, at the top of this page. Therefore, all radii are congruent. Definition of a circle. So if AG equals 12, then LA also equals 12. So just to jot down what I'm doing, I'm just going to say that all radii are congruent. So it's just so you see what I'm doing. So LA equals 12. Okay. Example 3. Okay. The diameters of circle A, circle B, and circle C are 10 inches, 20 inches, and 14 inches respectively. Find XB and BY. Okay. All right. So we're going to have to mark up this diagram as we do this. Okay. Let's start with the diameter of circle A. Okay. So again, it goes in order: A, B, C, 10, 20, 14. That's what respectively means. Okay. So the diameter of circle A is 10 inches. Okay, the diameter of circle A is 10 inches. So that means that AX is a radius, so AX is going to be 10 divided by 2. So AX equals 5. I know we were not asked for that, but that's the first thing that we need to do. Okay, now here's my next question. What is AB? What is AB? AB. The diameter of circle B is 20 inches. So AB is half of 20, so AB is 10. Okay, AB, I don't know if you can see this too well on the computer, but I just shaded in AB. AB is 10. If AX is 5, then XB also has to be 5, because 5 plus 5 equals 10. These don't have to be the same, okay, but they are the same in this example. Okay, these do not have to be the same. But since AB was 10, and this part was 5, segment addition postulate, this part also had to be 5. Okay. Next, I'm going to try to shade this in so you can see it. But next, I'm going to try to get YC. Let's get YC next. What is YC? Pause the video if you need to figure it out on your own if you want to do that. But YC. The diameter of circle C is 14 inches. So it means the radius is 14 divided by 2, which equals 7. So YC equals 7. Which means now we can get BY. Okay, there's a few ways you could do that, but remember, the diameter of circle B is 20, so all these have to add up to 20. The diameter of circle B is 20. 5 plus 5 is 10, plus 7 is 17, so BY must be 3. Okay, so find XB and BY. XB equals 5 inches. And then BY equals 3 inches. Okay. Moving on. The circumference of a circle is the distance around a circle. Circumference. The circumference of a circle is the distance around a circle. It is most often represented by the letter C. Notice it's a capital C, so you're going to use a capital C for circumference. For diameter, you use a lowercase d, and for radius, you use a lowercase r, but for circumference, you're going to use a capital C. Okay? And there's two formulas you need to know. Okay? The circumference of a circle equals pi times the diameter, or you can say it equals 2 times pi times the radius. Okay, so those are the two formulas. It's either pi times diameter or 2 times pi times the radius. You can use either one depending on what you have and what you're trying to solve for. Okay, so I have two pretty easy examples on those. Find the circumference of a circle that has a radius of 7 centimeters. Write your answer in terms of pi and as a decimal rounded to the nearest tenth. So this question is asking you to write your answer 2 different ways. Okay, no problem. So you got to figure out which formula you're going to use. And since we're given radius, it makes more sense to use this formula right here. So I'm going to say circumference equals 2 times pi times radius. The radius is 7. Now you're going to multiply the 2 times the 7. That's going to give you 14 pi. That's one answer. And remember, a lot of times people may think circumference is like inches squared or centimeters squared or feet squared. But it's the distance around the circle. So if you want to think about it as the perimeter, and that's not squared. It's just going to be 14 pi centimeters. Now, it asked you to write your answer in terms of pi and as a decimal. So that's the first answer. Now we're going to put it as a decimal. So I'm going to say C is approximately, and in your calculator, I want you to do 14 times the pi button. Don't do times 3.14, okay? if you do that, it's going to round too much. Just do 14 times the pi button in your calculator. 14 times the pi button. Round to nearest 10, I'm going to say 44.0. Approximately 44.0 centimeters. That question asked for your answer two different ways. Those are the two different ways to write your answer. Please note that this bottom answer is an approximation. This top answer is an exact answer. Okay, 14 pi is an exact answer. 44.0 is an approximation. Find the diameter and the radius of a circle that has a circumference of 136.9 meters. Round your answers to the nearest tenth. Okay, so we need diameter and radius. So I'll start by getting the diameter. So I'll do circumference equals pi times diameter. This time you know the circumference is 136.9, so make sure you substitute the 136.9 in for the circumference, not in for the diameter. And now in your calculator, you're going to do 136.9 divided by the pi button. Not divided by the 3.14, divided by the pi button. Round its nearest tenth, and you get 43.6 meters. Now, there's two ways to get the radius. So, you know what I'm going to do? I'm going to use the circumference again, just in case you accidentally made a mistake solving for the diameter. You could just take this number and divide it by 2, but if you got this number wrong, then your next number will be wrong. So I'm going to go back to the original problem. I'm going to use this formula now. $136.9. If you want to solve this for the radius, here's what you're going to do. You're going to do 136.9 divided by 2 times pi, but make sure you put the 2 times pi in parentheses. That way your calculator follows the order of operations properly. 21.8 when you round it. By using the original formula twice, by using the original 136.9 twice, it allows me to double check my answer to see if I actually did it right. For example, if I do 21.8 times 2, I should get 43.6, and I do, so I know I did it right. Okay. All right, 2 more pages. Find the exact circumference of circle P. In order to find the circumference, first of all, it says exact. That means you're going to leave your answer with pi in it. You're not going to multiply by pi and get a decimal because that's an approximation. This wants the exact circumference of P, so you leave the pi in there. But in order to find the circumference, we need the radius or the diameter, and we don't have either. But we can solve for that if we use the Pythagorean theorem. So I'm going to do 5 squared plus 12 squared equals, I'll just do D for diameter. Now, you might know this answer already if you memorize Pythagorean triples. If not, you're going to have to do all this work. So a 25 plus a 144 equals D squared. D is for my diameter, which is the hypotenuse in this case. 169 equals diameter squared. Take the square root of each side, and you get 13 equals the diameter. And now we can find the circumference. Circumference equals pi times diameter. That's from the previous page. Okay, remember? You have two formulas for circumference. I'm going to use the first one because I have the diameter. This is a good SAT problem. So we know the diameter is 13. And you're going to write the 13 first before the pi because it looks better that way, okay? Circumference equals 13 pi centimeters. Okay, that's the exact answer. If I said approximate or give a decimal, you just do 13 times pi. If I say give an exact circumference, that's the exact circumference. Now, I said you don't have to do this work out if you remember certain Pythagorean triples, like 3, 4, 5, 5, 12, 13. So you might have had that number memorized. But that's how you do that one. Okay. Example 7, find the exact circumference of the circle below. Now, you could do the Pythagorean theorem again if you wanted, but you don't have to, okay? But again, you see this is 9, and this is also 9 because it has one tick mark on it. So these are both 9. So you could use the Pythagorean theorem, just like we did in example 6, or you can use a shortcut. Do you know what the shortcut is? This side equals that side. So the isosceles triangle theorem says that the angles opposite them have to be congruent. If this is 90, then this angle must be 45, and this angle must be 45. You have a 45, 45, 90 triangle. The hypotenuse equals a leg times the square root of 2. So the hypotenuse, I'm going to call the hypotenuse D because it's the diameter. Okay? Diameter equals 9 square root of 2. Now let's go into the circumference formula. Circumference equals pi times diameter. And we just established what the diameter is. So it's going to be pi times 9 square root of 2. Now, the way you're going to write this to make it look nice is you're going to put the 9 first, then the pi symbol, then the square root. Square root always goes last. Inches. Okay. All right, moving on. 2 more problems, last page. Find the exact circumference of circle P. All right, so you probably know where I'm heading with this one based on the last example and based on that 30-degree angle. But if that's 90 and that's 30, then this missing angle up here has to be 60 degrees. And we have a 30, 60, 90 triangle. So when you use one of these, you're trying to find the hypotenuse because the hypotenuse is the diameter. Okay, so you're trying to find the hypotenuse. You have the long leg. Remember, I don't have any equations comparing the hypotenuse with the long leg because it's messy. So what I'm going to do for this one is I'm going to find the short leg first and then find the long leg. Okay, then find the hypotenuse. Okay, so find the short leg first, then find the hypotenuse. A 30, 60, 90 triangle, I'm just going to use SL for short. No pun intended. Short leg equals long leg divided by square root of 3. So the short leg, I'm just going to keep using SL, equals 4 square root of 3 divided by square root of 3. Okay, that's easy, good. The square root of 3 is divide out, and the short leg equals 4. Now we can find the hypotenuse because, again, I'll just write down 30, 60, 90 triangle. The hypotenuse equals 2 times the short leg. So in this case, the hypotenuse represents my diameter. So I'm going to use D for diameter. Equals 2 times the short leg, which we just established was 4. So the diameter equals 8. Now we can get the circumference finally, okay? Circumference formula. Circumference equals pi times diameter. So pi times 8. To make your answer look nice, I'm going to put 8 first and then pi. Circumference equals 8 pi. There's no actual units. I'm just going to write down the word units. Okay. This next problem is a really good SAT problem, and it's our final problem for today. In the figure below, triangle ABC is inscribed. We're going to talk about that later. It means all the vertices. It means like the vertices are on the triangle. We'll talk about that later, okay? Triangle ABC, that's a future lesson, I mean. It's inscribed in the circle with center O and diameter AC. If AB equals AO, what is the degree measure of angle ABO? Okay, you cannot guess. You should be able to know the answer based on what we've learned in this class already. If AB equals AO, let me label that. If these are equal, that means that they're congruent. So I'll put 1 tick mark on each. Okay. And my next question is, what's true about AO and BO? AO and BO are both radii, therefore they are congruent. So since each side of the triangle is the same, it means we have an equilateral triangle. So I'll say triangle ABO is equilateral. That means each angle is the same. So the measure of angle ABO, basically you're doing 180 divided by 3, in case you don't know the answer off the top of your head. But that means it's just 60 degrees. Each angle is 60 degrees in an equilateral triangle. It's a good SAT problem right there. Okay. And again, this is the new unit. This unit was called circles. That was the first lesson, circles and circumference.